Okay, this is going to be another video mostly centered around the Revolve function. In this case, instead of going with a freehand spline, we've actually got some defined points, and we want to make a curve from those points. We'll be using the Interpolated Spline tool. Reason being, it theoretically will go and hit every point that you put on it, although honestly, with an irregular spacing and number of points like this, it doesn't go that close. To do this for real, you're going to want to get a nice regular spacing and a good sampling of points going, from one end of the curve to the other. Alright, first things first, the points at the end points of this, and it's again for the fuselage of an RC sailplane, the end of the point doesn't come down to what I assume to be the axis of the revolve, in this case the x-axis. Because they don't come down to the end on either end, I'm left with the choice of either putting some points in, just interpolating by eye where I think the nose of this sailplane should be and the tail, or what I'm going to do, because it brings up some interesting things if I do it this way, is I'm going to assume that there is a solid bulkhead at the front and a solid bulkhead at the rear, and that there will be a nose cone and tail cone added later. Reason I'm doing this is it brings up some things that make for a pretty nice tutorial. Alright, the first thing I want to do is, because I don't have any points here for the lines that will define these bulkheads, I want to put them in. The easiest way to do that, because I am dealing with points that I know the coordinates for, this one is at 0.375x and 0.308y, and I also know the value for that one in the rear. I will define a line along the x-axis that has a 0.375 start point, so it starts directly below it, and vice versa on the end of it. So I go up to lines and coordinates. 0.375, 0y, 0z. This one is at 31.795. 0y, 0z again. Click OK. You see the line forms down there. Now the only reason I want this is so that I have an endpoint that I know the location of, so that I can drop a nice perpendicular line to the axis from this point down there, using the lines join tool. Bobcat, particularly with this tool, but in any entity that you want to see the snap points on, hold down shift, click on the entity, and it can be an arc or a line segment, number of things. You will get a snap point on the ends and one in the middle of most things. Obviously not things like a circle, but you'll see the snap points for them too, including the origin, the center point of a circle. So that's just a good thing to know. In this case, we're still in the line. Oh, no, we're not still in the line join tool. I canceled out. Line join. Highlight. Shift click. And click on that end snap point. It's good practice. You don't, on a big line that I know the end point is there and that there are no small lines around it, I can just click and it automatically, I know that it's going to that snap point. Sometimes you're dealing with things that you don't know for sure that this is one great big line segment, so it's a good idea to get used to the shift clicking system, just so you can see snap points. They're very handy in a lot of situations. Okay, I'm now done with that line. I don't want to use a pick revolve or a pick axis revolve, so I'm just going to trash this line. I've got a line for my forward bulkhead, a line for my rear bulkhead. The first thing I'm going to do, though, is I'm going to run an interpolated spline. And the reason I'm picking an interpolated spline is that theoretically it will hit every point on here. In practice, this isn't really enough points for it to do a good job. The more points you have, the better your curve. But you just highlight the snap points and click as you go. When you get to the end, click OK. And there's your spline. Now what we're going to do is revolve around the actual UCS axis there. So I go to Surfaces, Revolve. And in this case, I don't know the technical reason for this. I know how it works. I don't know why it works. On this bottom set here, all of these default to 0. If you take one of these and give it a value other than 0, doesn't seem to matter what it is, that is the axis that you will get revolution around. So in this case, I want to revolve around the x-axis. I just change it away from 0 to 1. I want to get a 360-degree revolution. Don't have to worry about caps or anything because I'm going to get 3 surfaces, a hollow tube, a disc, and a disc, or rather just a flat circular plane. I'm going to define and generate those 3 surfaces, and then I'm going to stitch them together into a solid. So I've got all those. What I want to do now is click on one end of the contour, shift and click on the other end of the contour. I've got my nice arrows there that are going the right way. Hit OK. And can't see that very well. Let me actually go to a right view. Now you can see, looking up the tailpipe of this thing, that it's hollow. And going back to front, or the top rather. Alright, what I want to do next is to do the same thing using these lines. So again, I go to Surfaces and Revolve. All my settings are still there. I still want to revolve around the same axes. So I click, shift click, tell it OK. And it has formed a surface there. I'll swing my view around over to right. There it is. Just to make sure I'm not clicking on the line up on the other end of this. There we go. Slew that a little bit. Click. Shift click. Got a good contour. Tell it OK. So now I've got my hollow tube, I've got a tail bulkhead, I've got a nose bulkhead. I want to stitch those together into a solid. So I go to Utilities, Stitching, Stitch Surfaces to Solid. And this one, very straightforward. I click on this one, I click on this one, I change my view around to left so that I can see the nose bulkhead, click on it, click OK. Now when I go to select, I'm selecting a single entity. Change my view around to the right side so that you can see that the tail is also selected. And that's pretty much it. Again, you will do better at getting a nice curve. This is obviously just a little wonky, not quite as pretty as I would like it to be, just because there aren't enough points in the data set. The more points you give spline, the better spline you get out of it. I hope you find that helpful, and we'll work on some more stuff later. Thank you.